To understand how the garbage collector works in Java, it is necessary to first understand what is garbage for Java. So, any object that is no longer in use, have no active references, is considered as a garbage object for Java. And the process of freeing up its memory is called garbage collection. At a very basic level, garbage collection consists of finding objects that are no longer in use and freeing up the memory associated with those objects. It is one of the most attractive features of Java that the developers need not to explicitly manage the life cycle of the object. The objects are created when needed, and when the object is no longer in use, the JVM can automatically freeze the objects. Now, let's talk about how it works. To summarize the process at a very basic and preliminary level, let's recall that each time an object is created in Java, it goes into an area of memory known as the heap. All objects, no matter when, where, or how they are created, they live on the heap. And the Java heap is actually a garbage collectible heap. Why so? Because when you create an object, Java allocates memory space on the heap according to how much that particular object needs. For example, an object with, say, 10 instance variable will probably need more space than an object with only 2 instance variables. But what happens when you need to reclaim that space? How do you get an object out of the heap when you are done? So Java manages that memory for you. When the JVM can see that an object can never be used again, that object becomes eligible for garbage collection. And if you are running low on the memory, the GC will run, throw out the unreachable objects, and free up the space for you so that the space can be reused. So, GC or the garbage collection process is dominated by the basic operations like finding unused objects, making their memory available, and compacting the heap. It is generally a two step process: mark and sweep. So, mark or trace, as we call it, means identifying which pieces of memory are in use and which are not. Marking that are no longer in use, and sweep means removing those objects that were identified during the mark phase. So, it generally starts from the roots, the thread stacks, and the statics, etc. Then mark everything it can reach as live and those it cannot as dead. At the end of the mark phase, all reachable objects will be marked as live and all non reachable will be marked as dead. And it's a linear process. So, if you talk about in terms of the algorithm, the mark and sweep algorithm involves two phases: marking and sweeping. During the marking phase, the garbage collector traverses the object graph from the root objects and marks all reachable objects. Then, during the sweeping phase, the garbage collector traverses the entire heap and frees any object that were not marked during the marking phase. This algorithm is simple to be implemented and works well for applications with relatively few objects and a relatively stable memory uses pattern. Wikipedia has provided an animated depiction of this process as well. So, this is mark phase and then this is sweep. It's a perfect depiction of the mark and sweep algorithm. But sometimes there involves a third step as well, and that is called compact or compacting. The compact phase of garbage collection works like this. During this phase, the garbage collector moves object to create larger, unfragmented areas of free memory. The garbage collector also changes references to moved objects to point to the new object location. An operation of this type might not occur because compaction is not always required. So some algorithms have this step and some do not. In simple words, compact involves moving objects together to reclaim the contiguous empty space, something like the defragmentation. Those who have performed the defragmentation on their window using the window utility, they must have seen that process going on. And a compaction process has to correct all object references to point to a new object location too. That is additional that it's supposed to do. So, as an algorithm, the compact algorithm involves three phases: marking, compaction, and updating references. During the marking phase, the garbage collector marks all reachable objects, just like in the mark and sweep algorithm. During the compaction phase, the garbage collector moves all live objects to a contiguous block of memory, freeing up spaces between the object. And finally, during the updating references phase, the garbage collector updates all references to moved object to point to their new locations. This algorithm is more complex to implement than the mark and sweep, but it is more efficient for applications with large numbers of short lived objects or that generate a lot of garbage. Some GC collector act as copy collector too, and copying collector moves all live objects from a from space to a to space and then reclaims the from space. And then we have the generational collectors as well, which is a broad topic. So JVM offers different types of GC collectors with options to tune them as per the application's requirements. We will explore these different categories of GC collectors offered by JVM in the next part.